Okay, guys, so this is part 2 of your identities lesson. So for the first part, what we were trying to do is trying to simplify everything so that we get like one term. Okay. This next part is what's called verifying identities, or another word for it also is what's called trig proofs. Okay. So essentially what you're trying to do is, if you look at the steps that I have here, the goal is to prove or show one side of an identity is equal to the other, equal to each other. Okay, so you're trying to show that both sides equal the same thing. Okay, now the clue is, or the big hint is, you want to use the side that looks more complicated. Now I'm sure that probably sounds a little bit funny, but like the side that has that looks more complicated has more information for you to use, and you have it'll help you simplify more. If you use the less complicated side, then you're going to get stuck. There's only so far you can go before you can't go any further. So typically use the side that looks longer or more complicated. And the clue here is, like, addition or subtractions are generally more complicated than multiplications. So if you see that, then use that side instead. So if an expression can be multiplied out, do so. If it can be factored, do that. If you can split it into a couple fractions, sometimes that'll be helpful. Or conversely of that, you can combine terms. It all depends on what you have on the other side. When in doubt, change everything to sine and cosine, because again, like I said, that you have a lot of things that are in terms of that. Okay, and like I said, sometimes you might work through it. It might not work right away. You might have to go back and start over again. Okay, there's nothing wrong with that. Sometimes you just have to do that. So again, that's what we're trying to work on here. So trying to verify these identities. All right, we want to prove one side equals the other. Okay. Now, typically what you want to do is only work on one side. You want to leave the other side completely by itself. All right. So for this first one, I'm going to work on the left side because it's got more terms. Okay. So if I see parentheses, right, I can multiply. So I'm going to multiply sine with both of these. Okay. So that gives me sine of theta times cosecant minus sine squared. Okay. Now, I know that cosecant is the opposite of sine. So if I substitute that in, okay, what is that going to give me, right? Sine of theta over 1 times 1 over sine is really just sine, or is just 1, right? So 1 minus sine squared. Okay, and if you look at your Pythagorean identities, right, sine squared plus cosine squared is 1, right? So then 1 minus sine squared must be cosine squared. Okay, so that is the same thing as what we had over here. Okay, so then we are finished. Okay, now this next one, I'm probably going to go with the left side just because of the fraction part. All right, now secant squared. All right, this might be helpful to put everything in sine and cosine. Okay, so secant squared would be 1 over cosine squared, right? And then tangent is going to be sine over cosine, right? Okay, now if I divide that out, right, I'm going to have 1 over cosine squared times the reciprocal of the denominator, which would be cosine over sine, right? Now, what could I cancel from that, right? I know that this one cosine can cancel out one of these cosines, okay? So what's that going to leave me with? That's going to leave me with 1 over cosine times sine. Okay. Now, if you look at what you have on the other side, you're pretty close to that, right? Now, what's another way to write 1 over cosine times sine, right? If I make that two fractions, I can do it like this. So 1 over cosine times 1 over sine. Okay, now what do you know 1 over cosine is? Secant. What do you know 1 over sine is? Cosecant. And that's what we have there on the other side. So that we are done. Okay. So letter C is same thing again, right? You're going to want to multiply out, all right? So if I do sine times cosecant, right, I already know that they are reciprocals of each other. So I know that that's 1, okay? And then if I do sine times the second term, right, we know that that is sine squared secant squared. Okay, so, can't really do anything with the 1. They don't have anything in common. So let's put everything in sine and cosine. So we could change the secant squared to be 1 over cosine squared, right? So now if I put this second term together, that's going to give me sine squared over cosine squared, correct? Now what's that change into? That's tangent, right? So you got tangent squared. Okay, and then if you look at your Pythagorean identities again, what is 1 plus tangent squared? That's going to be secant squared. And then you're done with that, right? Because that's what you have there on the other side, all right? So again, when in doubt, put everything in sine and cosine, and then it's usually pretty easy from there. Okay, so 2 cosine squared plus sine squared equals cosine squared plus 1. All right, so I'm thinking let's do the left side again. Now, they don't have anything in common, right? But 2 cosine squared, right? What is that the same thing as, right? If I gave you guys, like, you know, if you had 2x, right? What's another way to write 2x? Well, it's x plus x, right? Well, I can do the same thing with 2 cosine squared, right? I can make that cosine squared plus cosine squared. All right, just split it up into 2 terms instead of 1 term, okay? And then what do we know sine squared and cosine squared give me, right? If I put these together, I know that that's just going to be 1. Okay, so then that's what we have there on the right side. So then we are done. Okay, so some of these are a little bit more difficult than others. It all kind of depends on, you know, what you're given. So, okay, so 2 cosine squared minus 1 equals 1 minus 2 sine squared. Okay, so what one could I use? So I think this one would probably be similar to the last one, right? So if we just split it up, so if you do cosine squared plus cosine squared minus 1 equals 1 minus 2 sine squared. Okay, so what would be cosine squared minus 1? All right, so if we do sine squared plus cosine squared, we know that that's 1. All right, now what would, if I subtracted the 1 over, and then subtracted the sine over, right? This is going to give me cosine squared minus 1 equals negative sine squared, right? Okay, so let's do that. So let's do cosine squared minus sine squared. Okay, so this part here, cosine squared minus 1, we changed it into negative sine squared. Okay, so how else can we get? All right, so we have we have one negative sine squared, right? We need another one. Okay. Now again, if you go back to your Pythagorean identity, right? If you look at the first one, okay, what happens if you solve that for cosine squared? So cosine squared is the same thing as 1 minus sine squared, right? Okay, so we can make this part, right, 1 minus sine squared. All right, if I put that together, I'm going to get 1 minus 2 sine squared, which is the same thing as the other side. Okay, now let's see. I probably could have done this step here, probably from the get-go, and that might have saved us some steps, but that's okay. Again, multiple ways to do these, guys. There's not always one particular way. Okay, so I see that I have some exponents here. Now I'm probably going to want to multiply these out. That's probably going to be the easiest thing to do. Okay, so you need to FOIL everything out. Okay, so this is really sine of x plus cosine times sine of x plus cosine. All right, so that's going to give me sine squared plus sine cosine plus sine cosine plus cosine squared. Okay, so if I put that together, that gives me sine squared plus 2 sine cosine plus cosine squared. Okay, now if I do the same thing with this one, right, that's going to give me sine squared minus 2 sine cosine plus cosine squared, right? Again, all you're doing is you're foiling. You're foiling this out, right? Okay, so what's that give me? Okay, so well, I know that I can get rid of 2 sine of x and negative 2 sine of x, right? Now, what happens if I put sine squared and cosine squared together, right? I know that that gives me 1. And then what about sine squared and cosine squared again? That gives me another 1, which comes out to be 2, which is what you need. So we're done. Okay. So you got cotangent over cosecant equals cosine, all right? Sine and cosine again. So cosine over sine divided by 1 over sine. Okay, so if you simplify those out, cosine over sine times sine over 1, right? Sine's going to cancel. And we know that we have then just cosine. Okay, so that one's pretty easy. All right, for h. So like I said, the side that has addition or subtraction is probably the side that you want to use, just because you have more steps to do, and you could simplify a lot easier. So let's do sine over cosine plus cosine over sine. Okay, now how do I get these two fractions to make it one term, right? I'm going to need to multiply by a common denominator. So sine over sine with the first one, and then cosine over cosine with the second one, right? So that's going to give me sine squared over sine cosine plus cosine squared over sine cosine. Okay, so sine squared plus cosine squared is 1 over sine cosine. Okay, now how do you make one fraction? How do you make that two fractions, right? So this would be 1 over sine times 1 over cosine. Right, and what does 1 over sine become? Cosecant, and then secant, which is what we have on the other side. Now, I know it's not the same order, but again, multiplication, the order does not matter. Okay. Okay, so same thing here. We're going to use the left side because of the subtraction. Okay. Now, I know secant, right, is 1 over cosine. Okay. Now, we need a common denominator, right? So I need to multiply the second term here by cosine over cosine. So that's 1 over cosine minus cosine squared over cosine, right? So that's going to give me 1 minus cosine squared over cosine, okay? Now, what is 1 minus cosine squared? What is that going to become? So if you look at your Pythagorean identities, okay, 1 minus cosine squared changes into sine squared. Okay, now if you look at what we have, right, we have sine of x times tangent of x. Okay, what's another way we can write sine squared, right? If we expanded that out, right, that's really sine of x times sine of x over cosine, okay? Now, if I group the two together, if I group these two together, right, and I just keep rewriting, right, I have sine of x, the first sine of x, times sine over cosine, which, sine over cosine is just going to give you tangent, which is what you need, right? Okay. Letter J, all right, we have sine of x plus cosine of x times cosine over sine. Okay, so that's going to give me sine of x plus cosine squared over sine. Okay, so we're going to need a common denominator. So we're going to multiply this first term by sine of x over sine of x. All right, so what's that give you? You got sine squared over sine plus cosine squared over sine. All right, now you guys know, obviously, sine squared plus cosine squared is 1. If you put them together, you got 1 over sine, which is cosecant. All right, so I hope you guys are starting to get the pattern, the techniques down. I'm kind of doing the same thing every time. I'm looking for ways to use the identities and simplify it as much as you can. Now for this one, You probably could do either side. Now, I know that I have cotangent. Now, I could change that to cosine over sine. That's not wrong. However, the right side is in terms of tangent, right? We already have an identity from changing cotangent into tangent, right? I can make cotangent 1 over tangent, right? Okay, and then do the same thing on the bottom. So 1 over tangent minus 1, right? Now, this is something that we worked on earlier in the year, right? You have a complex fraction, right? How do you get rid of your complex fractions? You multiply by the common denominator, which in this case is going to be tan x. All right, so you're going to take tan x and you're going to multiply it to every term in the fraction. Okay, and then what does that give you? So tan x times 1 over tan x is just 1 plus tan x. And then tan x times 1 over tan x is also just 1 minus tan x, which is what you have there on the other side. Okay, so for letter L, there's probably a couple ways we could do this. I'm thinking you could change the top to make it tangent squared. That's perfectly fine. All right, what's another way? Okay, I see that I have a single term here in the denominator, right? So just to kind of mix it up now, right, we can make this one fraction into two fractions, right? So what that'll do is you'll have secant squared over secant squared minus 1 over secant squared. Okay, how does that simplify? So you got 1 minus 1 over secant squared is cosine squared, and then what's 1 minus cosine squared? Sine squared. Okay, so that's one way you could have done it. Another way, again, you could change secant squared minus 1 into tangent squared and then put everything in terms of sine and cosine. I just did it a different way just to kind of mix it up. All right, and then for letter M, okay, again, we're looking to get a common denominator. Okay, so the first one, 1 plus sine over 1 plus sine, and then the second one, 1 minus sine over 1 minus sine. Okay, so what's that give me? So I got 1 plus sine over 1 plus sine times 1 minus sine. Again, I'm not going to multiply the denominator out just yet. If I have to do that later on, I will. But for right now, I'm just going to leave it as is. And then the second one is 1 minus sine over 1 plus sine, 1 minus sine. Okay, so now they have the same denominator, right? If we put them together, right, that's going to give me the sine terms are going to cancel, right? And then 1 plus 1 gives me my 2. Okay. Now you got 1 plus sine, 1 minus sine. Okay, now if you look at what we have, right, we need to make this 2 secant squared. Okay, now right as it is, if we see parentheses, right, we probably want to multiply out. So maybe that'll help us get a Pythagorean identity that we can rewrite. Okay, so if you do that, okay, that's going to give you that's factors of a difference of 2 squares, right? So that's just 1 minus sine squared, right? And then that looks like a Pythagorean identity, right? So then you got 2 over cosine squared, right? And then now you already know that 1 over cosine, right, is secant. So that's then what is 2 over cosine. That's 2 secant. All right, so this now just becomes 2 secant squared, which is what we need. Okay. And then the last one here. Now you got a bunch of different terms, and again, probably makes sense to just change everything to be sine and cosine. So you got 1 over sine plus cosine over sine divided by sine over cosine plus sine, right? Okay, so I could put the top together, right? Make that 1 plus cosine divided by sine. Okay, and then on the bottom, that's going to give me, how can we put that together? Well, we're going to need a common denominator, right? So sine over cosine, and then I'm going to need to multiply this sine of x term by cosine over cosine, right? Remember, this is just sine over 1. So what's that give me? So that's sine cosine over cosine, right? Okay, so now we got 1 plus cosine of x over sine of x divided by sine of x plus sine of x cosine x over cosine x, right? Okay. Now another way that you could write this part here, right? What do they have in common? They have a sine of x in common. So I'm going to factor out that common sine term. So that's sine of x times 1 plus cosine x over cosine x, okay? Now, you have one fraction being divided by the other one, right? So let's rewrite that. So 1 plus cosine x over sine x times the reciprocal of the denominator, so cosine x over sine x 1 plus cosine x, right? Okay, what can we get rid of? So I can get rid of 1 plus cosine, all right? Now let's keep an eye on what do we need on the other side? We need cotangent and cosecant. Okay, so cotangent and cosecant. All right, so if I simplify out this 1 plus cosine out, right, that leaves me just 1 over sine. And then the second term, cosine over sine, right? Now, what do you guys know 1 over sine becomes? Cosecant. And then cosine over sine becomes cotangent, which is what we need on the other side. Okay, so that is how you guys do Pythagorean identities. All right, I ran through a bunch of different examples just to kind of give you some ideas of how you can go about these. Biggest thing for this is you just got to practice it. The more you do it, the more you'll recognize the techniques and things like that. So again, if you guys have any questions, let me know. Thanks.